Good morning, dear students, and welcome to Vista's Learning, an online educational platform. My name is Denzil, your physics tutor for class 11. So let's get started with today's session. So in the previous session, we dealt with one of our bridge courses, which is the basic arithmetic operations. Basic arithmetic operations that were used on different types of number system that were natural numbers, whole numbers, integers, and rational numbers. We in fact studied in detail about a rational number, how to conduct an operation like addition, subtraction, multiplication, and division on a rational number. But today's session, we will be discussing some of the concepts that are related to trigonometric functions. So let's get started with today's session. This is a session 2 of a bridge course. So to begin with the trigonometry function, first we need to understand some of the trigonometry ratios. You may ask the question, why is trigonometry that important to us? Is there any application based on trigonometry functions and trigonometry ratios? The answer is yes. There are numerous number of applications that is dealt using trigonometry. One such example that I can give you is, in order to identify the height of a Mount Everest, you cannot carry a measuring tape all the way from the bottom to the summit of a Mount Everest. Now, if you think that is practical, then I'll be really surprised that actually someone could do that, take a measuring tape from the bottom of the Mount Everest all the way to that's the Himalayas. So what could be a better way in order to measure the height of a Mount Everest? That would be by using trigonometry functions and trigonometry ratios. So let's get started with what are the various trigonometry ratios. First of all, trigonometry, the one surprising fact about trigonometry ratio is, to study a given triangle, particularly for a given right angle triangle, you'd use Pythagoras Theorem, where it states the sum of the squares of the hypotenuse is equals to the square of the sum of the square of the two adjacent sides is equals to the square of the hypotenuse. Or it could be put in the other way around. The square of the hypotenuse is equals to the sum of the square of the two adjacent sides, which are right angle to each other. So using Pythagoras theorem, now to identify one of the parameter, let's say to identify the height AB, you must be aware of the two different parameters, such as the length of AC and the length of BC. Now, surprisingly, what trigonometry does is, it creates a shortcut in order for us to identify the height AB. It says that it's not necessary for you to measure the length of AC and BC. All you could do is give me a couple of hints as to one of the measure of the length and what is the angle at which the given line is inclined. And interesting. So here we will notice some of the trigonometry ratios. Some of the trigonometry ratios that you might have learned from your NCERT textbook in class 10. And those trigonometry ratios are sine, cosine, tangent, cotangent, secant, and cosecant. So these are the various trigonometry ratios that you might have come across in your 10th standard. So let us reflect on that. Quick recap as to how these trigonometry ratios can be identified using this right-angled triangle here. Now, you can write it in a short abbreviated form of these given ratios For a sine, you just write it as sin, but you still call it sine. Okay? Though it is mentioned as sin, it is an abbreviation for sine. Now, what are abbreviation? A short form that are given for a given lengthy or for a given word. Okay? So, sine, cosine is just by writing cos, tangent is tan, cotangent is cot, secant is sec, and cosecant is cosec. Now, these are the abbreviated form of a trigonometry ratios. Now, what else do these trigonometry ratios need to have? Angle. We identify each trigonometry ratio with respect to the angle of a right angle triangle. For this, I will take my angle which to be located at C. I will call this angle, I will represent this angle by the letter theta. This letter is a Greek letter theta, alright. So, theta is to represent angle. So, each trigonometry ratio is described or is identified with respect to a certain angle, and the angle is located here at C. Now that we have the angle, next we need to find the ratios of these trigonometry ratios, which are sine, cos. We need to find the ratios. Since we're dealing with trigonometry ratios, we need to find the ratio of sine theta. So first we mention what are those various sides called. Now first of all, how to identify now three different sides, the three different sides that you have learned, that you will come across even here. The three different sides is one, opposite side. Okay, these are the various sides. One is the opposite side, two is the adjacent side, and three is the hypotenuse side. Now, for you it is very easy to identify the hypotenuse. You could just say this given line AC is the hypotenuse, a simple task. But what about the opposite and the adjacent side? Now, first what I want you to do is take a look at where the right angle triangle is, where the right angle is placed. Now, this right angle is located beside the two lines. The two lines create a right angle. So, these two lines, one of them should be opposite, the other one should be adjacent. But which one is which? The line that is opposite to the angle. So, this is the line which is opposite to the angle. So, the line that is opposite to the angle is called the opposite side. Easy. So, I'll just write op to show you it is the opposite side. Similarly, the line that is beside the angle, the line that is beside the angle is what is called the adjacent side. And you're left out with the last one, which is hypotenuse. So this is how you can identify for any given right angle triangle which is opposite, adjacent, and hypotenuse. So now let us write those ratios for this given trigonometry, which is for sine theta, cos theta, tan theta, and various others. Sine theta is ratio when you take opposite by hypotenuse. So which is the opposite side? The opposite side is AB and the hypotenuse side is AC. So AB by AC. Next is cos theta. Cos theta ratio is adjacent by hypotenuse. So adjacent by hypotenuse. Which is the adjacent side? Adjacent side is BC and hypotenuse is AC. So BC by AC. Third one tan theta is what we have as opposite by adjacent. Well, you're aware of opposite side already, which is AB. Adjacent side is BC. So you have opposite side, which is AB, and adjacent side, which is BC. Next is cot theta. Cot theta, surprisingly, is the inverse of tan theta. So all you have to do is reciprocal the given ratio, so which would be adjacent by opposite, which is BC by AB. Similarly, secant theta is the inverse of cos theta, meaning it is the reciprocal of the ratio of cos theta. So cos theta is adjacent by hypotenuse, so secant theta will be hypotenuse by adjacent, which is equals to AC by BC. And guess what? Cosec theta is the inverse of, well, there's one last trigonometry ratio that's pending, so why not? Sin theta. So which means you reciprocal the ratios of a sin theta, which becomes hypotenuse by opposite, which is equals to AC by AB. And there you have it. This is how you identify the given trigonometry ratio when a certain angle theta is mentioned. So students have difficulty, in general students have difficulty in order to understand how to recognize the opposite, adjacent and hypotenuse for a given triangle. Let's say if the given triangle which is mentioned in such a manner, where you have right angled at this position, let's call it A, B and C. Now can you identify which one is opposite, adjacent and hypotenuse? Difficult, isn't it? So first of all, we will have to specify where is the angle located. Because in the previous case, the angle here was located at C. But if the angle is located at A, then the whole ratio will change. The ratios will change just because this angle is located at a different location. So similarly, in this case, we need to specify where is the angle. Let's say the angle is located at A. I'm taking for a given trigonometry ratio, angle located at A. Now, how would you identify, given this current information, how would you identify the adjacent, hypotenuse and the opposite? Now, two things. So I actually use three rules. So keep in mind three rules. Rule number one, identify where right angle is here. Rule number one, identify the right angle, correct? So to this right angle, you have two lines that are perpendicular to each other. So these two lines, one of them should be opposite, the other should be adjacent. So this may be opposite or adjacent, or this may be opposite or adjacent, which means if two of these things are opposite or adjacent, the third one is known to us, which is, see, a very easy way to identify the hypotenuse. Rule number one, identify right angle triangle. You have two lines that are perpendicular. Third line will be hypotenuse. Rule number two, identify, locate where the angle is. Angle is located here. Rule number two, locate the angle, the line that is opposite to the angle is called opposite side. So which means this line is opposite to angle, therefore it is called opposite side. Simple. So it is not adjacent. So you can actually find using only two rules, but I'll give you a third rule as well. Third rule is identify or locate the angle. The line that is beside the angle will be the adjacent side. So this will be adjacent side. So this is how you can identify for any given right angle triangle where opposite, adjacent and hypotenuse are located. Now that we have seen some of the trigonometry ratios such as sine theta, cos theta, tan theta and many others, what if I specify an angle for that given theta? So these angles that I'm going to specify are what are known as standard angles. Some of the standard angles that we use in trigonometry are 0 degree, 30 degree, 45, oops, I'll change the color there so that may not be visible to you. 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So these are the four standard angles that we will use in order to identify what their values are or what values they give. So the various trigonometry ratios are sine theta, cos theta, tan theta, cot theta, secant theta and cosecant theta. So these are the angles theta. So now how to identify the values when theta is 0, 30, 45, 60, 90. So I will teach you a trick how you can identify the following, how you can find the values for the given trigonometry ratio when such and when so are the angles 0, 30, 45, 60, 90. You ready? So here's a trick. You start with writing the number 1, 2, 3, 4, oh, start with 0. No, so sorry, start with 0. Let's not start with 1, start with 0, 1, 2, 3, 4. I thought I could place 0 there. So, okay. Start with 0 there. 0, 1, 2, 3, 4. Next, divide all the numbers by 4. 4. 4. And then you take the square root of these individual numbers. Identify what the values are. 0 by 4 is 0. Square root of 0 is still 0. You see, we've identified the first angle already. Sine 0 is 0. Next, 1 by 4. So you can take square root as an individual. Square root of 1 is still 1, but square root of 4 is 2. So 1 by 2. See, we've identified the second angle for sine 30. Now this can be simplified as 1 by 2 because 2 by 4 is an equivalent form of 1 by 2. So square root of 1 by 2, 1 by root 2. Why? Is because square root of 1 is 1, whereas square root of 2 is a prime number, which means you cannot take a square root. If you take the square root of 2, it becomes an irrational. Anyway, square root of 2 itself is an irrational number, meaning it's non-terminating, right? And non-recurring numbers. So similarly, if you work out for 60 degree, root 3, again a prime number, root 3 by 2. And then you have 4 by 4, which cancels, giving you 1, and square root of 1 is 1. Ta-da! We have identified one of the trigonometry ratio values. Its standard angles when sine 0 degree is 0, sine 30 degrees is 1 by 2, sine 45 degree is 1 by root 2, and sine 60 degree is root 3 by 2, and sine 90 degree is 1. Now let's find it for cos. Cos is a very simple technique. All we need to do is take the values of sine and write it in the reverse order. So yes, we write it in the reverse order, all the given values as so. Ta-da! So here you have the values for cos. Interesting. Now one fascinating part about trigonometry ratio that you might have learned is tan is closely related to cos and sine. So how is tan related to cos and sine? Let me make a note of here. Using the red ink. Tan theta is equals to is a ratio of sine theta by cos theta. You don't believe me? You can go ahead, write down. You already have the ratio for a sine theta. You already have the ratio for cos theta. Where did we do this? In the previous section. In the previous section, you see you have the ratios for sine theta and cos theta. Divide one another, that is AB by AC divided by BC by AC, you will get AB by BC, which is tan theta. This is how you can prove that tan theta equals to sine theta by cos theta. Now, similarly, to find the values of tan theta here, you divide sine theta and cos theta. 0 divided by 1. Oh, change the ink. Change the ink to black. Is 0. 1 by 2 divided by root 3 by 2. Well, you can go ahead, try to identify, and you will get 1 by root 3. 1 by root 2 divided by 1 by root 2, 1. Root 3 by 2 divided by 1 by 2, root 3. 1 by 0. We saw this in the earlier section. In the first session of bridge course, I told you for a rational number p by q, q cannot be equals to 0. When q is not when q is equals to 0, then you get a number which is not defined. You cannot divide any number by 0. You can go ahead and try it in your calculator. Type in 1 divided by 0. It does not calculate. It shows a symbol E, which is error, or it will just mention as an error. So this number, which is 1 by 0, is not defined. So I'll just write it as ND. ND to show you it is not defined. Very easy way to calculate sine, cos, tan. Now, it's still fun to calculate cot, secant, and cosecant. Why? Here's fun relation between cot and tan. I'll write it. Here's a fun relation between cot and tan. Tan theta, or let me start with cot theta. Since we're dealing with cot, so I'll do cot theta. Cot theta is equals to 1 by tan theta. So which means it's just the reciprocal of tan theta. To find the value of cot theta, reciprocal tan theta. So let's do that. Reciprocaling meaning 0 will become 1 by 0. 1 by 0 would be not defined. 1 by root 3 reciprocal becomes root 3. 1 by 1 is still 1. And root 3, when you reciprocal, it becomes 1 by root 3. And 1 by 0, which is not defined, when you reciprocal, it gives you 0. So technically what you could do is write it in the reverse order for cot. A very simple trick, taking tan and writing it reverse order for cot. Secant theta, fun relation for secant theta. Secant theta is closely related to cosine. So secant theta is equals to 1 by cos theta. So they're close related, which means whatever value you have for cos theta, reciprocal, and that will give you the value for secant theta. So this is already known to you. I'm just revising it one more time. So 1 by 1 is still 1. Root 3 by 2 is 2 by root 3. 1 by root 2 reciprocal becomes root 2. 1 by 2 reciprocal, it becomes 2. And 0. 1 by 0 is not defined. And finally, last, which is for cosec theta. Now, definitely you know this cosec theta is close related to sine theta because he's the only one that's left out. So let's not keep him lonely. So cosec theta is 1 by sine theta. So which means to find the value of cosec theta, you take the reciprocal of sine theta. 1 by 0, not defined. 1 by 2, 2, 1 by root 2, root 2. Root 3 by 2, 2 by root 3, and 1 by 1 is still 1. Fun way to identify all the given trigonometric values for standard angles, trigonometry ratio values for standard angles such as 0, 30, 45, 60, and 90 degree. Easy? All right, let's move on to the next. Trigonometry ratios of complementary angles. So what does it mean for a given angle to be complementary? Let's take for this given triangle, which is a right angle triangle. The angle, let's say, is located at C. If the angle is located at C, I want to identify a given trigonometry ratio in a different form where the angle is located now at A. So let's say theta prime. So different ratios. Let me give you an example. Let's say sine theta. Okay, sine theta. I'll erase this part, which is theta prime for now. We will soon get to that. Okay, sine theta, which is located at this point here. So how would I mention this ratio? The ratio will be opposite, which is AB by AC, which is good enough. Now, if I have to write it in this form, let's say the angle is located at this point. So this angle would be 90 minus theta. Why would this angle be 90 minus theta? That's because you see one of the angle is 90 degree. So sum of these two angles should be 90 degree. Why should sum of these two angles be 90 degrees? Because sum of all the interior angles of a right angle triangle is, or any triangle is 180 degree. So out of that 90 degrees already mentioned. So the remaining two should be 90 when you add them. One is theta, the other is 90 minus theta. All right. Okay. So using the same principle where if I write AB by AC as the ratio for sine theta, what will it be AB by AC for 90 minus theta? Right? This is the adjacent and this is the hypotenuse for 90 minus theta. Because for 90 minus theta, this would be the opposite. BC would be the opposite, whereas AB will be the adjacent. So AB is the adjacent and AC will be hypotenuse. Adjacent by hypotenuse. What trigonometry ratio does it give you? Cosine. So which is equals to cos, and the angle is 90 minus theta. So sine theta is equals to cos 90 minus theta, and that is what we see in this case. Cos 90 minus c. Now that I've just mentioned theta, but if you take it as the letter angle c, then here you have 90 minus c. Yes? I will show you one more. Which one shall I choose? Which one? Okay. I'll choose this. Okay. Okay. So let us try to prove this one. Tan C. First of all, tan C is equals to opposite by adjacent, which is AB by BC. If this is C, this angle here will be 90 minus C. Agreed? Instead of writing theta, I've just mentioned C. This is angle C, so this will be 90 minus C. The angle is located here. The new angle is located here. Since the new angle is located here, for this angle, with respect to this angle, opposite line will be BC and adjacent line will be AB. So AB is adjacent. BC is opposite for this angle. So which means it gives you the trigonometry ratio which is for cot. Cot, and what is the angle? 90 minus C. Therefore, tan C is equals to cot 90 minus C. So this is how you can prove the following as to how one trigonometry ratio is closely related to the other when the two different angles are taken into consideration. So let us look at few examples of how to solve such trigonometry ratios for a complementary angle. Tan 26 degree, cot 64 degree. How do you solve this? How do you find the answer? Now first, what you notice is they are not of a standard trigonometry ratio. It is not 30, it is not 0, 45, 60 or 90. So how do we solve? Now here's what we do. Take one of the trigonometry ratio, let's say tan, convert it into cot. So how do you change it to cot? Very easy, where you write cot 90 minus 26 divided by, it's too big, cot 90 minus 26 divided by cot 64. And how did this happen? How did this happen? Is by using the concept which is for a complementary angles, how one trigonometry ratio changes to the other. Alright, so 90 minus 26 divided by, and then cancels to give you 1. Easy problem. Let's have a look at another. Tan 48 degrees, tan 23 degrees, tan 42 degrees, tan 67 degrees. Whoa, that's a lot there. So how would you solve this problem? Well, take any of the two trigonometry ratio. I'll pick these two because when I change them, they're closely related. When I change these two, notice what happens. I get cot 90 minus 48 times cot 90 minus 23, and then you get tan 42 degree and tan 67 degree. Cot 90 minus 48 is cot of 42 degree. Cot 90 minus 23 is, that's cot of 67 degree, tan 42 degree and tan 67 degree. Now, one interesting fact about product of cot and tan, cot theta times tan theta is equals to 1. The product of these two is equals to 1. Well, if you don't believe me, you can have a look by using the ratios. Earlier in the first section, we discussed about the ratios, how a given trigonometry function has a ratio, which is a opposite by hypotenuse. In a case of cot, you have which is adjacent by opposite. In case of tan, which you have opposite by adjacent. Well, eventually you see that they cancel and they turn into 1. So similarly here, I have cot 42 degree, tan 42 degree. It is the same as writing cot theta into tan theta. So these two will get cancelled to give you 1. Similarly, cot 67, tan 67 will cancel to give you 1. So your homework, remember, is to prove that cot theta times tan theta equals to 1 is by using those ratios, opposite, adjacent, and the hypotenuse. Okay, so yeah, there's another question. If tan 2a equals to cot a minus 18, where 2a is an acute angle, find the value of a. This is a very simple problem, and these problems are obviously found in your NCERT textbook, a simple, easy problem. Tan 2a is equals to cot a minus 18. Okay? Tan 2a can be changed into cot, where you write cot 90 minus 2a is equals to cot a minus 18. Since both the side you have cot, the angles have to be the same. Since one is equals to the other, the angles must be the same. So which means taking only the angles, 90 minus 2a is equals to a minus 18. Bring all the a on one side, all the numerical on the other side. So you get 90 plus 18 equals to a plus 2a. 90 plus 18 is 108 equals to 3a, where a is equals to 108 by 3. And you divide by 3, and what you get is 36 degree. All right? Okay. And finally, here we are at trigonometry identities. And Balaji, manual the time, please. Time. Okay. All right, trigonometry identities. How do we prove that this given identity is true? Now, here's what you can do. We have a right angle triangle. To this right angle triangle, we apply Pythagoras Theorem. What is Pythagoras Theorem? Where you have the square, the sum of the square of the two sides is equals to the square of the hypotenuse. Now, to these three sides, what I do is I will divide them by AC square, AC square, AC square, and AC square. When I divide them by AC square, what I'm left out is with AB by AC the whole square plus BC by AC the whole square is equals to AC square cancels to give you 1. AB by AC, if the angle is located here, AB by AC, AB by AC, meaning opposite by hypotenuse. Opposite by hypotenuse, trigonometry ratio is sine. So you get, let me write it as sine C. Okay, so let's not worry about the theta. Sine C, since it's a square, so sine square C, plus BC by AC, BC by AC, adjacent by hypotenuse, which is cosine. So cos square C, which is equals to 1. Hence, proved that sine square C plus cos square C is equals to 1. And that is one of the trigonometry identity. You have another trigonometry identity, which is 1 plus tan square C plus is equals to secant square C. So let us try to prove the following again by using Pythagoras theorem, is where you have AB square plus BC square is equals to AC square. Now to all the three, I will divide them by BC square. BC square by BC square by BC square. Angle is located here, keep that in mind. BC, AB by BC whole square plus cancel to give you 1 is equals to AC by BC whole square. AB by BC, opposite by adjacent, angle is located here at C. Opposite by adjacent is tan. So tan square C, since it's a square, plus 1 is equals to AC by BC, AC by BC. Now if you look into your trigonometry identities, where the ratio AC by BC is for secant, where you have secant square C. That is how you obtain the following identity, where 1 plus tan square C equals to secant square C, tan square C plus 1 equals to secant square C. So this is how you prove. Well, the last one, you go ahead and try to prove this. This one will be your homework. Okay, try to prove this, where cot square C plus 1 equals to cosec square C. So I hope you have learned a lot about trigonometry ratio. Now the surprising fact is that there is a lot more. So we just cover only the basic. So to get more details about the classes, do visit us at www.we-learning, so you can have a look at some of the bridge courses that we have conducted for 11th and for 12th standard. So thank you for joining me. I'll see you all in the next session. In the next session, we will have some more of the bridge course, which are closely related to the topic of 11th standard. So take care everyone. Have a nice day and bye-bye.